Hi everyone, Jean-Charles Cabelguen speaking. Please call me JC. I'm very pleased to be here today. I'm the Chief of Innovation Adoption at iExec. I'm also the Chair of the Trusted Compute Task Force at Enterprise 330am Alliance. So the title of my presentation is From the Cloud to the Edge. We talked about how blockchain could be the essential layer for building hybrid IT infrastructure and creating new business models. So we will follow this agenda. First, we talked about the first IT trend, the edge computing on hybrid infrastructure. Then we will talk about multi-party IT systems. Then we will see how the zero trust would make sense for new business models, new architecture. And we will see after that how blockchain can unite those three IT trends. And then we will illustrate these ideas through two use cases, and then we will conclude in illustrating what new business model can come next. So before that, let me introduce to you iExec. iExec has built a decentralized cloud computing marketplace, and iExec helps enterprises to leverage off-chain computing and to also leverage trusted computing. We come from a background in distributed computing. We did an ICO in April 2017 and we raised 10,000 Bitcoin. So today we are close to 30 people working in France from here. Here are some of our industrial partnerships, but I won't go into the details. So I would like to start with the first IT trend, edge computing. So what is edge computing? The concept of edge computing is to put computation, storage, and services where it's needed on the field. The idea is to have a low latency and to decrease the bandwidth. It's easy to understand the interest of edge computing using this illustration. If we have an augmented car that is connected to public cameras, we can see the interest of having low latency infrastructure. We can imagine having a camera, being able to analyze that a kid will cross the street. We doesn't want to have a computation saying to the car to decrease the speed or to stop. That will take too much time. So when we use classic cloud infrastructure, you have to put the data inside the data centers. Those big data centers are often far from being in center of cities, and then to send back the result of the computation. The idea with edge computing is to have a small data center everywhere around the cities and to be able to compute fastly what is needed. It's very close to what we have observed regarding 5G. 4G was this idea of having big antennas sending radio signals, and 5G the idea of having a bunch of small antennas all around the city. And when we think about smart city and the need of being able to connect billions of devices, we see the interest of having edge computing infrastructure sustained by those small data centers everywhere in cities. And we have also information saying that this trend is growing fastly. Today, the global market is around 3 billion and it's forecast to be close to 70 billion in 2025. Nevertheless, we don't forecast edge computing being standalone infrastructure. For sure, in the future, we'll have a hybrid infrastructure, meaning cloud data centers, big cloud data centers, being able to store data, and edge data centers, small edge data centers on the field, being able to fastly compute services and provide services with low latency for the users. Next party is about multi-party IT systems. When we think about smart city, supply chain, smart factory, we know that we will have thousands of companies that will provide services while using several infrastructure. Meaning that those companies will own sensors, cameras, etc., in order to collect information to provide services. Here is the first use case, the concept of decentralized advertisement. We have an on-demand access to an advertisement screen to feature ads. We are using blockchain, off-chain computing, hybrid computing in order to have a decentralized marketplace where it's possible for companies and for individuals to feature their advertisement. This structure is used for authentication, order management, resource management, and also the automation of the payments. So you can see on this video that we have a big screen that is used for advertisements. It's possible for a company to buy time of screen and time of CPUs to showcase an advertisement. Here we have selected iExec release, and this idea is to be able to automatize and decentralize the way of how advertisement works. So the company is selecting some work parameters and validating the payment through the blockchain. And at the end of the process, they can monitor for how long time the advertisement has been featured and to automatize the payment and the reward of the owner of the screen, but also of the owner of the CPUs that has been used during the process. It's also compatible with edge computing devices like a smartphone. So you can imagine that I'm going closer to the idea of the need of blockchain. But before that, I would like to talk about zero trust. I remember end of 2018, I had a lunch with the chief of security from a $3 multi-billion company. It was in Seattle, in the US, and I asked to them, what is for you the important trend regarding IT tech? And everyone, three of them replied, zero trust. Zero trust is really what is important to develop and to incorporate in our workflow. And zero trust, it's really interesting because this idea of zero trust says that trust is a vulnerability. Before, we wanted to protect companies from data coming from outside and from attack coming from outside. And the idea of zero trust is to say that even what is managed inside of a company should not also be trusted. We should have technology, we should have a workflow managing everything from the outside and the inside. So the concept is to develop services with zero trust by design in order to gain the trust from users and also to address compliance policies. And what is interesting in that approach is instead of having a contract saying you can trust us, we won't copy your data, companies will deliver services saying that by design, they won't be able to copy the data. They won't be able to tamper a result because they won't have access directly of those informations. And zero trust is not one technology. It's a layer of technologies. And one of them is hardware enclaves. And we can see, for example, that Google has launched a confidential computing program, and iExec is really honored to be part of this program. It's just an illustration about how big companies are addressing this approach. So, to summarize my previous slides, I talked about hybrid IT systems, the mix of edge computing and cloud computing, multi-party IT systems, meaning that different companies are working together, and also the zero trust by design. For the first one, we'll have a lot of hardware heterogeneity. For the second one, we'll have software heterogeneity and also the need to manage the trust. And for the third one, IT system with zero trust by design, it will be like a mix of hardware and software heterogeneity and also the need to manage the trust. So maybe blockchain could be a solution to gather and to unite those trends, because we will need a layer of interoperability managing different standards of hardware, managing different standards of software, and providing a trust by design in order to allow those collaborations. Is blockchain the magic tool for that? Not exactly, because we need to connect those classic IT infrastructure to blockchain technologies. For that, off-chain computing is very, very valuable. The idea of off-chain computing is to build a bridge between the non-blockchain world and the blockchain world. The idea is to leverage the strengths of blockchain. Blockchain is really powerful because it's distributed, decentralized, immutable, transparent, trustless. But it has some lacks. For example, it's not good to store information. If you want to store an ID or an event, blockchain is perfect. If you want to store a video or the result of a computation, it's not on blockchain that you should do that. So you have to have an off-chain solution in order to put the result of a computation off-chain and to add the ID of the result of the computation in the blockchain, for example. It's also interesting to use off-chain computing for to address the scalability issue of the blockchain. And the idea is really to have a mix of off-chain computing and blockchain in order to have this layer of interoperability. Let's illustrate these ideas. So the first use case is decentralized advertisement. Let's imagine a scenario where we have an advertisement screen that is publicly available. Everyone can project, feature his advertisement on these screens based on the decentralized marketplace. So for that, we have used blockchain, off-chain computing, and hybrid computing in order to provide the possibility for companies or for individuals to use an advertisement screen and to showcase the ads they want to have. So we manage the 4 steps, the authentication. If I am a company, I want to be authenticated in order to be able to place an order and to have access to the screen of the advertisement. We have also the idea of resource management. We want to be able to have access to CPUs or GPUs to compute the projection, the feature of the advertisement, and also an automatization of the payments and rewards in order at the end of the process to reward the owner of the screen advertisement. So let's use this video for that. So here is the screen that is used for the advertisement. The idea as a company is to have access to the screen with the decentralized marketplace that will manage the disponibility of the screen, that will manage the pricing of the screen. So I have to upload an image, and that is the advertisement I would like to be featured. And after that, the marketplace will manage to find CPUs or GPUs in order to be sure that we will be able to compute the advertisement. When the advertisement has been featured, everyone at the end will be rewarded. The company will pay automatically the owner of the screen, and automatically will pay also the owner of the CPUs or GPUs that has been used during the process. The idea is also to be able to do that in the edge, using smartphones, for example, and everything is centralized, decentralized and automated. So the next use cases, it's the concept of autonomous delivery robots. So in the future, we have delivery robots delivering food, for example. And in this scenario, we use the idea of 2 delivery robots that were lost. They were lost in a parking place and they need assistance to come back to the base. In this demo, we use 5G as the communication layer. We use hardware enclaves, in this situation, Intel SGX, as a security layer. Think again about the idea of zero trust. And we use blockchain and chain computing as the interoperability layer to manage the authentication between the robots, to manage a proof of contribution, meaning that a robot should contribute and provide something that is valuable, and also to manage a reward, because behind those robots there are companies. So we were really pleased to work with Intel on this demonstration. We were invited at Mobile World Congress last year, and we were on the booth of Intel in order to showcase what we have done in that situation. So in this video, we are saying that the same idea, smart cities will have billions of connected devices. Those connected devices can be autonomous, can provide autonomous services. In this situation, 2 robots are lost. They need a rescue service. They send the information on the decentralized marketplace, and a third company responds to this request in sending a robot. And this robot is equipped with a LiDAR camera. This camera allows the robot to map the environment where the delivery robots are lost. When they connect together, they authenticate together, validating that they can collaborate together. The rescue robot sells the map that has been measured to the robots that were lost, and they use this map to come back to the base. When they arrive to the base, the map, and because of the quality of the service, and they automatically paid the company that is behind the rescue robot. The idea is really to say that we'll have autonomous vehicle lost in the future. We'll have connected devices that will need services from other companies. And we want to be sure that they can collaborate together in a secure way. So we need to manage the authentication process. We want to be sure that they can provide right services to each other. So we want to validate that the service has been well provided. And we want also to automatize the process of reward. If you want more information about this demo, you can go on the software.intel.com. We'll find an article about ISAC and the collaboration with Intel. So what next? Machine-to-machine economy. The idea of having edge computing infrastructure is to give the possibility of machine to provide services to each other, as we have just illustrated before. And the idea is to have minimal interventions from human, even no intervention from human. But for that, we need that machine are autonomous and connected. And it's not easy when we have millions of small machines working together to validate what has been done. So here there is an illustration from the UK government financing micro robots to work underground. Because it's micro robots, because it's underground work, it's really difficult to validate how they have collaborate. If those micro robots are owned by different companies, it will be difficult at the end of the month to validate which company should be paid more than the other. So for that, as I said before, we need technical layer managing the interoperability of hardware and software, different hardware and software standards. We need governance solutions. We need traceability of what is done, and we need automation of micropayments. And finally, on this slide, I would like to illustrate how cloud computing resources can be used in the DeFi industry. DeFi means decentralized finance. We think about connected devices from all over the world being able to gather computing power, data sets, and application. We can imagine that we will create highly valuable data sets. And we can put under the umbrella of NFTs those data sets in order to provide tradable DeFi data sets in the future. And those highly valuable data sets can be used as collateral for loans or for business relationships management. For example, banks having KYCs that are highly valuable because they have information regarding their clients can use those KYCs as collateral to work with other banks to have access to KYCs also. And the idea is to use what is already done in the classic finance and to add these financial vehicles on top of the new digital asset we are building and we will create. Thanks for your time, and feel free to ask any question. I was very pleased to be here today.